Hello and welcome back to another episode of Math with Sohn. Today we are going to be solving systems of equations using the substitution method. Let's get into it. For our first problem, we are going to have two equations. That is what a systems of equations is. So I got 4x plus 2y equals 10 as my first equation. And my next equation is going to be x is equal to a y plus 13. So a system of equations has two equations and normally two variables, and you can solve this equation, or any systems of equation, using one of three methods. We can use substitution, that's what we're learning today, elimination, or graphing. Now, substitution method works best when you have a variable already by itself. So in this case, x is by itself. X equals y plus 13. So one of the two equations for substitution to work out easily would have a variable already by itself. In this case, x equals that y plus 13. So because I already have that by itself, I already kind of know what x is equal to, I can replace the x in the other equation, that one right there, with a y plus 13. I can substitute this y plus 13 in for that x. So what that would look like is I would have a 4, and then instead of writing x, I write what x is equivalent to, which is y plus 13 plus 2y will equal 10. So I just replaced that x with the y plus 13. From here we have a single equation with a single variable. We can solve like normal with substitution. That normally means you have to distribute. We get 4y plus 4 times 13 is 52 plus 2y equals 10. Combine like terms. So we're going to combine 4 and 2y together to get 6y plus 52 equals 10. Subtract 52. 6y will equal negative 42. 10 minus 52 is negative 42. And divide by 6. And you will get your y is equal to, in this case, negative 7. Now, because this is a system of equations, we have an x value and we have a y value that we will have to find out. Now, because I have the y value, I can now use that to plug it into either of the two equations. I can plug it into either one, but I'm going to plug it into the easier one, which in this case is the bottom equation. I'm going to plug in negative 7 for y there. So I would get x equals, replacing the y with what I found out y was, negative 7 plus 13, which in this case, x would equal negative 7 plus 13, 6. Now, a lot of times teachers will want this written as a coordinate point, which really just means that you have to write it as 6, comma, negative 7, x, y in point format. If you ever want to check your answer with any of these, because sometimes you feel like you made a mistake, you can plug this point into the other equation that we haven't really plugged it into yet to see if it works out there as well. And if it does, you will have gotten it right. I'm going to do that just to demonstrate. We could have 4 plugging in the x as a 6 plus 2 times a negative 7. And if this is a correct answer, this had better equal 10. If it doesn't, we messed up somewhere. 4 times 6 is 24. 2 times negative 7 is negative 14. And does that equal 10? Does 24 minus 14 equal 10? Absolutely. That means that we got it right. And 6 comma negative 7 is the answer for x comma y in coordinate point form. All right. So for our next problem, we're going to have a y equals a 4x minus 9 and a y equals x minus 3. Now for this problem, you have two variables. You have the y equals and the y equals. These are both already solved for, and that just means that substitution is going to be that much easier because you already know that y equals 4x minus 9. And because of that, you can substitute it in for that y right there. And you could also think of it as y equals 4x minus 9 and y equals x minus 3. Well, that must mean that 4x minus 9 would have to equal the x minus 3 via the transitive property. But you could also think of it as just plugging in the 4x minus 9 for that y, substituting it in. Either way, you're going to get an equation with one variable, 4x minus 9, equal to x minus 3, that you can now solve. Subtract x from both sides. 4x minus x is 3x. Minus 9 equals negative 3. I'm going to add 9 to both sides. 3x will equal 6. And when we divide 6 by 3, you get x is equal to 2. From here, you're not finished. You have to plug this x value into one of the two equations, the top two equations, to figure out what the other variable is, in this case y. So I'm going to plug in 2 into the bottom equation. The bottom equation is by far easier. So I'm going to plug in 2 there. Y would equal 2 minus 3. I plugged in 2 for x, which means y will equal negative 1. And I have my coordinate point, 2 comma negative 1, x comma y. Real quickly, you could plug it in your head and see if that's a true statement. If I plug in 2 for x in the top equation, 4 times 2 is 8, minus 9 is negative 1 for y. So that also works, and we have our coordinate point. For our last problem, we are going to have a quadratic equation. And what makes it a quadratic is that x squared and the 5x. And because of that, we are most likely going to have 2 solutions, because that x squared indicates that we will have normally 2 values for x. So I got my top equation and my bottom equation. We are still going to use a substitution for this. And y equals all this stuff, the x squared, the minus 5x plus 7. And I can replace this y with that. I can substitute all of this in for that y. So I am going to do that now. I'm going to write x squared minus 5x plus 7 equals 2x plus 1. And we can now realize how we have to solve this. Because we have an x squared and an x, we are going to have to factor. And in order to factor, the first step in factoring is set the problem equal to 0. Well, right now I don't want to get the x squared negative. It's already positive, so I'm going to move the 2x and the 1 to get the right side of the equation equal to 0. In order to move the 2x, we subtract. In order to move the 1, we would also subtract the 1. That would go away. That would go away. You get x squared minus 7x. 7 minus 1 is positive 6 equals 0. So I just added and subtracted straight down. Now that we have it equal to 0, and we did that because we're going to have to factor the x squared and the 7x, because there are both of those we have to factor, we will have to figure out, because of factoring, what multiplies to 6 but adds to negative 7. So if it helps, you can list out your multiples of 6. 1 times 6 would multiply to equal 6, and 2 times 3 would multiply to equal 6 as well. And out of those, the one that will add to 7, and in this case negative 7, would be a combination of a 1 and a 6. So I'm going to write out my parentheses, because that's what my factors are going to be. I'm going to put an x there and an x there. I know it's going to be a 1, I know it's going to be a 6. In order to multiply to positive 6, but yet still add up to negative 7, they're both going to be negative. So we have our 2 factors. Now that we have our 2 factors, we have to individually set them equal to 0 to solve. We add 1, x equals 1. We add 6, x would equal 6. So we got our 2 solutions for x. For x, we haven't found the y values yet. And for those of you that haven't realized with factoring, normally your solutions, the x equals 1 and x equals 6, are just the opposite of the factors. That's normally the case. It's not a coincidence. All right. Now that I have both of these values for x, I am going to plug them in to find the value or values for y. I'm going to plug in the 1 first. I'm going to plug it into the bottom equation because it looks a little bit easier. So we get y equals 2. I'm plugging in the 1 for x times 1 plus 1. Make sure you're plugging in for the correct variable. If this is y, we'd have to plug it in for y. We get y equals 2 times 1 is 2 plus 1 makes 3. And right here, I'm going to pause, and I'm going to write this as my coordinate point. X is 1, and y is 3. That is a coordinate point, and that is combined, and those are locked in together. So x is only equal to 1 when y is equal to 3, and 3 for y is only when x is 1. All right? For our next answer, we're going to have to plug in the 6, and it's going to have its own coordinate point. So we're going to plug in the 6. We're going to get 2 times 6 plus 1. Plugging it into the bottom equation. 2 times 6 is 12 plus 1 makes 13. So we got our second y value, and I'm going to plug those as a coordinate point linked together, 6, 13. Forgot my parentheses, 6, 13 as a coordinate point. So the two real solutions here are the coordinate points. It is not okay for you to just say x equals 1, x equals 6, y equals 3, y equals 13. It is only when they're linked together that they happen to be solutions. It's the coordinate points that make them the solutions, not the x equals and the y equals by themselves. All right? So that's going to be doing it for today's episode of Math with Sohn. Until next time, have a great rest of your day. Bye.